so looking at this lovely picture that we have up here, how about an x-intercept?
4, 0.
4, 0. Huh? And that's just the same as the root, right?
Yep.
It's the same as the root. Okay. How about a y-intercept?
0, 2.
0, 2. Looking good. All right. How about a vertical asymptote? X equals 2. Beautiful. Good job. You just guessed. Now, part of the reason why I actually gave you guys this problem is you should be able to sort of just guess at some things. Some things should look a little bit obvious. If we look at this guy, he has a vertical line, a little empty spot right here, right?
Yeah.
Okay. That is our
Asymptote.
vertical asymptote.
So it's going to be
So that's our vertical asymptote. How about the horizontal one?
y equals 1.
Y equals 1. Good. Same idea, right?
Yeah.
We'll look at for the little space. Now, they get a little harder than that, but that should be a hint, right? All right, how about domain?
Everything greater than... No, x doesn't equal 2.
It just can't equal 2, right? Do you see that we didn't use the 2 at all? So x just can't equal 2.
What? But they're like, there's no, you don't know that for sure.
Yes, you did.
No, you actually do that. You'll see why in a little bit. Yeah, just bear with me for a little bit, and there'll be a reason for that. Next. You could, but most of the time we get lazy and we just say x doesn't equal 2. It's just shorter. Yeah. There's nothing wrong with what you said. You just won't see it typically that way.
So, the domain not equal vertical, no, it's not equal upward.
Ah, so you saw a little connection here. Do you see it?
Oh, wow. Yeah, and then y.
Okay. Now, I'll warn you, okay, it does look like this guy doesn't cross the 1, right? Just like if I drew a little 1 right here across here,
Yeah.
okay, it looks like it won't equal that. Okay. Sometimes it does. You just have to be picky about it. But this one, you're right. Y does not equal 1. So far, so good? All right, now if we're looking at this next guy, okay, what's the problem with him? I don't have a graph. So what should I do?
Graph it.
Graph it in your calculator. Okay, so pull up your calculator. Let's graph it there. Now, I will warn you that when we graph it here, I gotta get out of that.
Put it in parentheses.
Put it in parentheses. Yes, definitely. So put the top in parentheses and put the bottom in parentheses. And if you don't have your calculator, use Desmos or the little Android app if you have access to that.
Whoa.
This is a weird.
I don't like
It's like.
Now this is a little bit of a weird one.
Really weird.
Huh?
So it's like.
Now yours may look even weirder than mine.
So it's like a negative 1, 0.
Because what happens on your calculator is, and I actually couldn't even see it on here, but if you press mode, you may see an option for connected or dot. Right now, by default, your calculator is set for connected. So what the calculator does on yours is it kind of comes along here and it draws this piece. And then and when it gets to the highest point possible over here, it says, oh, I need to connect that down there to that piece. And it does this. Huh? Now, my graph is correct though. Okay? So these lines are actually not there. Now you can fix that on your calculator by changing it to dot if you like, or you can just mentally ignore them. The dot makes it look weirder because what then it does is just kind of puts a few dots in here and it's harder to see. So I usually just mentally ignore them. If you have a newer calculator, it'll probably look just like mine. Yeah. So yours looks just like mine. So this is what it should look like. So I'm going to slide him over here for a moment.
Oh, shit.
Okay. So let's see what we can kind of fill in.
The x-intercept is negative 1.
Okay, I'm hearing that we have an x-intercept at -1, 0.
Would you say 0, 0, 2?
Huh? What do we think? Which is it, or is it both? Well, it's kind of hard to tell right here. Shall we pull the calculator back up and look? How can we check it on the calculator? Yeah, we could do intersect. So now if I'm going to do intersect, though, I need a 0 down here, right? Okay. Right. So I can do that and do intersect. I also heard, let's look at the table. Now look at my weird table. What do you suppose I did to my table?
Change the settings.
Yeah, I changed the settings. Okay. Now this is something that you guys asked me to fix on yours all the time because we used it earlier and you didn't remember how to fix it. How do we fix this? If we change the settings on our table, how do we set it back?
Second window.
Yeah, second window. And we want to change this guy. We want this independent to be auto. All right, and that'll just show us more of a table. All right, so I'm way up there, so let me scroll back down towards the middle here. I want you to see where I'm at, because I pressed it a lot. Thinking. What are you noticing about these values while we're watching our scroll?
That they're getting big.
They are getting bigger. Oh, that's interesting. They're getting bigger.
Oh, -1.
I don't know what it did. Just like lost itself there somewhere.
Oh, it also is 0, 0.
Yeah, so do you see there's 2 here, -1, 0, and 0, 0? Yeah, there's 2 there. All right, so let's do that. -1, 0, and 0, 0. How about the y-intercept?
0, 0.
That's 0, 0. How about the vertical asymptotes?
I mean,
X equals -3 and X equals
X can't be.
Beautiful. X equals -3 and X equals +3. So could we go ahead and do our domain? Yeah. X can equal 3 and X can equal -3. Now how about the horizontal asymptote? Yeah, it looks like it goes below the 1, maybe a half.
Yeah.
Okay. Now, since this one is a little bit harder to tell, go ahead and flip over on your piece of paper and read the definition of a horizontal asymptote. Somebody volunteer to read it for me. See?
Horizontal line equals that graph approaches. Value of y or f of x as x approaches positive or negative infinity.
Okay, that's good. So notice it said the value of f of x, was that it? As, or y, as x approaches infinity or negative infinity. So in other words, what's y when x gets big or small? Okay. So could we use the calculator, assuming that mine is no longer having a spasm? It still is, but maybe it'll come back to me here. That's so weird. Alright, I don't know what my calculator's issue is. Alright, but you guys bear with me here while I'm going to shut it down and open it back up again. Okay? So on your calculator, remember how we just fixed the table? Yeah? Remember how we just changed it to auto? Unfix it. So go back, second window, and change it back to at. Okay? Let me see if I shut it. There we go. Alright. Independent, yep. So we're going to do second window, right? And we're going to change this guy down here to ask. Now, the reason that we're going to change this to ask is because we want to look at really big values of x and really small values of x. So changing it to ask like this allows me to not have to scroll. Now I can just put some things in. So I can put in -10, that's fairly small. Right, and it tells me that the thing is at 0.49. So was our 1/2 sort of close to that, right? Right, but is -10 very small? Not really in the scheme of things. So what's something smaller than -10?
-1 million.
Okay, well, that's definitely smaller. I'm just going to put some random. Is that smaller?
I think so.
Yeah.
A little bit.
Look at there. Now notice, it's not really exactly 0.5, but is it pretty close?
Yeah.
Yeah, so it looks like on that end, it's approaching 1/2. Now those are small values of x. What should we also check?
Large.
Large. So let's put in a a large number.
1, 2, 3, 4, 5, 6, 7, 8.
One time I jammed up my calculator doing this, it didn't let me much. Ah, same thing?
That one's more. That one's.
Now that one's a little
one's
bit,
lower.
that one's actually, I added 4 digits. So is it even closer to 1/2?
Yeah.
So our horizontal asymptote is y equals 1/2. Now, be careful with kind of then saying, oh, that means the range is. Because notice this guy has this little lump in the middle. See him?
Yeah.
Okay. Now the 1/2 is telling you what's happening on the ends, not what's happening in the middle. So is it possible that this middle guy can actually cross the 1/2?
Yes.
Yes. Now here's what we're going to do. We're going to check it though. So I'm going to go back into my calculator. Hello. He's just not happy at all today. Oh, there he is. I'm going to type in, instead of y equals 0, I'm going to type in y equals 1/2. Huh? Right? And I'm going to take a look and see if he intersects anywhere. Yeah, it kind of, now, does it look like he intersects in the middle here? No, it doesn't look like it. We could zoom in, but it might over here. You see it? Okay, so let's do second trace. 5. Now, I'm going to move over there, which will take me, actually, I'm going to shift curve so I can slide along that guy. If you want to shift curves, you can just press the up arrow. And it'll shift you to the other curve. I'm going to try to slide over to that one. And I'm going to press enter 3 times, and we'll see. Ah, look at there. Did it hit the 0.5?
Yeah.
Yeah. So that means that my range is actually what? All real numbers. Okay. So all real numbers. Okay. How's that? Okay. Now, so you come to class, it's the day of the quiz, and you have forgotten your calculator. Uh-oh. Does that make that guy kind of hard? Yes. So let's talk about how we can find some of these without the calculator. So notice right underneath this I have factored form. Let's factor this guy. So what do you notice about the top? They have an x in common. All right, so let's factor that out. So we're going to have x times x plus 1. Okay. What do they have in common on the bottom? A 2. Now I'm going to actually do this right here. So it'll be x squared minus 9.
Perfect.
Can I? Yeah. X squared minus 9 is a difference of squares. So that is x plus 3 and x minus 3. Okay? Now what we want to look for are where are there some patterns? And what can I use to find these things without actually having to graph it?
The asymptote.
Yeah, so you see the asymptotes right here. Look right there. There they are. What happens if I put a 3 down there on the bottom? And for x?
0.
That makes that 0 on the bottom. Do we like 0 on the bottom of a fraction?
No.
No. It is undefined. Now, check this out on your table.
There's an error there.
Okay? If I put in, come on, one more. I put in a 3
Error.
or a negative 3, it gives me an error because it's sticking a 0 down there in the bottom. So if I gave you a new function and said find the vertical asymptotes, where could you look to find them? In the bottom. Okay? So here we look for the denominator equaling 0. Good? All right, you see anything else?
X
Carmen? You see it?
Oh.
Huh?
Good one.
Yeah? Now, notice I'm not writing anything right here right now because that's actually, there's a different situation for each one. We're going to talk about that a little bit more. Yeah, you see the 1/2? That's exactly where it came from, right there. Alright, what else? Now we know this guy came from here, right? Yeah.
All real numbers outside of the
Because it's outside of the. Oh, so you're talking about the 1/2, and the reason, so it could be a 1/2 because it's outside. I won't say that that's not true, but I don't know that it's always true. I'm not sure.
Of the x.
Yeah, well,
Well, it's -1, 0, and you put -1
if I plug in a -1 right here, I get a 0. Yeah. Does that apply for the 0, 0 also? Like if I plug a 0 here, won't I get a 0 on the top? Yeah. Now, what part of the fraction has to be 0 in order for the fraction to be 0? The top. So I could do this guy by setting the top equal to 0, or the numerator. Top just fits better. So the top is equal to 0. Right? Now, y-intercept, actually, we've known how to find y-intercepts forever. What's the definition of a y-intercept? Right? So look, if I put a 0 in here, I get 0 times 0 plus 1 over 2 times 0 plus 3 and 0 minus 3. So I get a 0 on the top, and on the bottom I get 2 times 3 times -3. So that's what, -18? Right? 2 times 3 times -3. -18. But 0 over anything is? 0. So I can just plug in a 0 for that. So to get this guy up here, I can make my top equal to 0 and solve it. To get my y-intercept, I can make x equal to 0. To get my denominator, or to get my vertical asymptotes, I set my denominator, the bottom, equal to 0. So the only thing that's now confusing is this horizontal asymptote and this stuff, right? Now domain, what did we say it related to?
The vertical.
Yeah, the vertical. And that definitely is a direct relationship. Okay. Range is a little bit harder. Okay. So like the range on this one, I could set this one equal to 1/2 and try to solve it. And that would tell me whether it was equal to 1/2. So range is a little harder. But let's talk about horizontal asymptotes a little bit. Okay? So again, let's flip it over. We said that horizontal asymptotes, I'm going to add in a page right here just so that we have some place to work. We said horizontal asymptotes was the value of y as x got really, really big or really, really small. So let's do a couple of examples with just horizontal asymptotes. You don't need to write these down, but you might want your calculator. Yes. Which would be why we learned how to factor first. That would be why. All right, so let's start with this guy. Let's go 3. Huh? All right, so let's find the horizontal asymptote for that guy. So one option we said was to put it in the calculator and look at big and small values of x, right? Okay. All right, so why don't you put it in the calculator and look at big values and small values of x. Don't forget to put that denominator in parentheses. He's crazy looking. Yep.
What?
Huh? Now notice something. You see this guy right here? Look at him. Where's that falling at right there? That's falling at 3. Why? X minus 3. If we said x minus 3 equal to 0, what do we get out? 3.
That's a big line
So-
going up.
So the vertical asymptote was at x equals 3. Now mine, I'm going to zoom out a little bit so you can see the whole thing. So let's look at it a little bit further out.
Oh.
Yes? Okay, so if you zoom out, you should see something similar to that. Okay, so what's it doing at the end? What's its end behavior? Yeah, this is getting bigger, right? Going to infinity, and this one's going to negative infinity. Now that horizontal asymptote definition said it had to be the number that it approached. Is this approaching anything? No. So if we go back to our table, let's see if I have it set. Did I change it back? No. Okay, if we go back to our table and look at this, if I plug in smaller things here, what's happening to y? What's happening here?
They equal the exact same thing. X equals y.
No. Okay. Now notice what's happening. Okay, these are getting smaller, yes? Okay, those are getting smaller. Okay. If I plug in bigger values, what's going to happen? It's going to get bigger. So does this one approach anything? No. No. Horizontal asymptote. So the horizontal asymptote, it has none. Okay. It doesn't approach anything. Remember that the horizontal asymptote is the value that the function approaches as x gets larger. Why did I put dA x equals 3 there? That was the vertical asymptote. So we were practicing there, Carlos. Alright, are vertical asymptotes and horizontal asymptotes the same thing?
Yep.
Okay. Alright. Okay, so let's try another one. Let's just flip him over. Now, before you grab him, what's his vertical asymptote going to be?
X. 1 and negative 1.
What's his vertical asymptote going to be? Remember, the bottom has to be equal to what?
0.
What makes x squared equal to 0? 0. Okay, so his vertical asymptote will be
0.
that. Okay. All right, plug him into the calculator and take a look at him and see if you can figure out what his horizontal asymptote is going to be. X minus 3 divided by x squared. The horizontal. Ooh, I love him. He's so cool.
It's like,
Just by deleting the ones that are there. You can just also write over top of them. So what do you think he is? What does it look like he is as far as his horizontal asymptote?
0.
It looks like 0. All right, so let's check it out. So if we go to our table, now you guys are still confused by some of these. Let me go ahead and get rid of some of those.
oh yeah.
Okay. So negative 1, 2, 3, 6, 5. Now, look at this. This is scientific notation. Negative 8 e to the negative 5. Is that a big number or a small number?
Whoa.
A really small number.
Ah.
Okay, so that's pretty close to what?
0.
0. Now, if I go a little bit bigger, let's say negative 0.5. Okay, that says well, that was a positive, sorry. Negative 0.5. Okay, that's negative 14. That's not really close to 0, right? Okay. But if I go out a little further, that's getting closer. If I go out a little further, that's getting much closer, yeah? Now, is it going to have the same thing going to happen on the other side? Like if I look at the bigger ones?
Yes.
Yeah, same thing happens. So this one, the horizontal asymptote, is y equals 0. Good? So far? All right, last one. Up. Now for something completely different. Huh? Now we could make him, let's make him even more interesting.
Calculus. 2 squared x.
So I had 2x squared. Okay. And then what did I put? Minus 3?
Here.
Or minus 3. Parentheses. Divided by x squared plus 1?
Yes.
Huh? Ooh. Now, does he have any vertical asymptotes?
Oh, no, he doesn't.
No, he doesn't. Now, let's look at why that is. If I have x squared plus 1 down here, does that factor at all? No. Matter of fact, if I tried to solve that, if I took that and tried to solve that for its roots, I would have roots that were what?
Complex.
Complex. So he has no vertical asymptote. It just doesn't have one. How about a horizontal asymptote, though?
Yeah.
Huh? Where does it look like it is? Remember, we're looking at the ends here, so could we go back to our table and look at the big and small values?
Yeah.
Yeah. Oh, it looks like it's pretty close to 2. Yes? Yeah, pretty close to 2. Let me use an equally big number here. Yep, 2. Look good? Alright, so this one has a horizontal asymptote at y equals 2. Now what we're trying to do is we're trying to make a connection between the equation and its asymptote. So we're going to go back to the definition. Now the definition said, I'm going to get rid of this. The definition said, ooh, I got a lot of them, don't want to cut him, The definition said it was the value of what? Flip it over. Got it. Value of y as x approached infinity or negative infinity. Now I'm going to work with infinity because it's just a little bit easier. This is the very important conceptual part of this. This is the very important conceptual part of this. Right? And if you can get this, you'll remember these asymptotes. There won't be a problem. Okay? All right. So it's the value of the value of y as x gets big. So let's look at this equation, this first one. I'm going to stick really big things in for x. Which is going to get bigger more quickly, the top or the bottom?
The top.
The top. So we call this top heavy. How do we know that that's going to get bigger more quickly?
This is getting
Because it's squared versus the bottom, which is just the first degree, right? Okay. So it's going to get bigger on the top. Now, if I think about fractions, if I write a fraction, let's say I do 2 over 2, and then I'm going to keep the 2 on the bottom, but I'm going to make the top bigger. He's going to be, and then I'm going to make him this, and then I'm going to make him this, and then I'm going to make him this. What's happening to the fraction as I make the top bigger? The fraction is getting bigger. So remember, this was that one that looked like this, right?
Yep.
Okay. So as I made it x smaller, it got smaller, and as I made x bigger, it got bigger. Hence, it didn't approach anything. It just kept getting bigger and smaller. You with me? You good? All right, so let's look at the next one. This guy right here. If I put really big things in there for x, which one is going to get bigger more quickly? So what do I call this one?
Bottom heavy.
Bottom heavy. Huh? Now, if you ask last year's class or the year before that, they'll tell you the little trick. Okay? All right, top heavy, bottom heavy equal. They get it. Okay, and I'll share it with you later if we have time. Okay. All right, so this one's bottom heavy. So think about these fractions again. Okay. This time, if I keep the top the same and I make the bottom bigger, what happens to the fraction?
Smaller.
It gets smaller. It approaches
0.
0. See what I mean? Huh? Now, why did the bottom get bigger here?
To the second degree.
Because it was to the second degree. It was a squared on the bottom. Yes? So if I wanted to write another one that was similar to this one, I'm going back here now. Give me one that would have no horizontal asymptote.
X.
Yes? That one's top heavy, yes? Okay. What about another one for here?
X minus 4 of X.
Yes, that one's bottom heavy, right? Now, look at this one. If I put really big numbers for x in here,
They're top.
right? But only by how much? So, as a side note, if I had $1 million charged to my credit card,
I don't even know.
yes, okay, and I decided I just had to have that Snickers bar, and I charged the Snickers bar, is that going to make a huge difference when I already have $1 million? No. So, you see this minus 3? Here's how it relates to this. You see this minus 3 and that plus 1?
Yeah.
Do those make much of a difference? Is x gets really, really big or really, really small? No. So those don't really make much of a difference.
But in the middle.
Now if I just had that, what could I do with the x squares?
Cancel them out of there. Whoa.
Do you see it?
Oh, that's
Okay.
Oh
So
my God.
with this one, okay, they are equal. Okay. And when they are equal, they get bigger at an equal rate, but in the ratio of their leading coefficients. So let's say I wanted this one to have a horizontal asymptote at 2/3. Then I would need to have a 3 down there.
Whoa.
Yes? Okay. And you can put that one in and see if it has a 3. Now this one's going to be a little bit, it'll actually like put something else out here because otherwise it'll just be a line. But you can put that in the calculator, see if it comes out to 2/3. Yes? Does that make sense? So that's the top heavy, bottom heavy equal. Alright?
What's
They
the
used a
strict?
visual representation. And they said top heavy was Dolly Parton. I think Nicki Minaj was bottom heavy.
Yep.
Hey, get it.
And then I think they used Beyonce as the other one, but I can't remember who the third one was now. But equal, I don't know. I don't know. All right, so let's kind of go back and fill in. Okay. Oh, no, I want to be back over here. Back. All right. So let's fill in our definitions, okay? So can you flip the sheet over and we'll fill in our definitions? We'll have it all there. So an x-intercept. All right, so we're working with all these rational functions, and a rational function is whenever we have an x in the denominator. So if there's an x in the bottom, it's a rational function. So an x-intercept is where the function crosses the x-axis. It's the value of x when
Why 0?
y is 0. And to find that, what did we say? What was the trick? We wrote it over here on this one. Top equals 0. We're not quite to that point yet. So we're going to say the top, set the top equal to 0, and solve. Y-intercept is where the function crosses the y-axis. It's the value of f of x or y when x is 0. How did we find that? Y-intercept. You wrote it down on that other one.
it's the ones on the out.
Nope.
X.
Yeah, it's x equals 0, guys. We just plugged in 0 for x, remember? We plug in 0 for x and simplify. Now, if it so happens that when you plug in the zeros for the x, you end up with a 0 on the bottom, what does that tell you? We're talking y-intercepts. No solution, yeah. So if we end up with 0 down here, then it has no y-intercept. Okay. Undefined. Alright, so vertical asymptotes. Definitions are there. The value of x as y approaches, so that's kind of that little vertical part. Okay. From the graph, how did we figure out what the vertical asymptote was from the graph? Look for the vertical space, yep. So we looked for the vertical space. What was the other trick? I showed you a trick with the table.
Plug in big and
No, it's not vertical. It's not vertical then. No. What happened in the table if I had a vertical asymptote? You got an error. Remember the vertical asymptote is what makes the bottom 0? Okay. So we can look for an error in the table. Now, I'll tell you that's not the most efficient method because often the table only has like 1, 2, 3. It doesn't have like 1.3. So it's not a real efficient method. The best method, though, was to use the equation. Where did we look in the equation for the vertical asymptote?
it's not.
The denominator, yep. So we set the denominator, otherwise known as the bottom, equal to 0, and we solve it. Okay, last little bit. Horizontal asymptotes. This is what we were just talking about. To find it from the graph, can we look for the little horizontal gap? Can we look for the little space there? Horizontally? Yeah. Right, we also used the table some. What did we do with the table? Big numbers, good. So we plugged in. We used the ASK features, right? We plugged in large and small values of x. Now from the equation, this is where we did that little top-heavy, bottom-heavy equal thing. Right? So top-heavy. How do we know when it's top-heavy?
The top has a higher.
The top has a higher degree. Okay. So this was larger degree on the top. And when it had a larger degree on the top, we had none. Remember, it just kept getting bigger. Then we had bottom heavy. That was the larger degree on the bottom. Okay. What happened then? What kind of asymptote did we get?
0.
0. So it bottomed out at 0. And then we had, it was equal, right? Right? Top and bottom were the same degree. And what did we do then?
Divide.
Yeah, we just really ended up keeping the what?
Coefficient.
The coefficients, yes. So our asymptote was y equals the coefficient over the coefficient. Okay, guys, grab this homework sheet, please. This is due on Tuesday. Okay? It's due on Tuesday. Grab it.
Carlos, can you grab one?
All right.
Hey, Carlos, could you grab me one?
Carlos, can you grab me one?